Well, hey, this is stream number 21. I'm going to be rewriting the scan keys function tonight, and I'm going to address a couple problems. So this code started out with just doing the matrix scanning, and I tried to extend it to handle mod tap. That's what this MT stands for here. And I got it sort of working, but it's got some bugs in it. And I kind of quickly realized that I am doing it on both keyboards, which is not good, because really the mod tap behaviors really should only be done on one board. And so I thought to myself, well, there's that, and then there's the other problems in that I have several different new pieces of state information in here, like this. There's the simulated keys, and there's active keys, and it's really not clean, this code. I kind of regret the way I wrote it, so I'm going to redo this, and I think I want to separate it into a couple different parts. So just some notes here. That's weird. The scrolling behavior is kind of odd. So first we got to do debouncing. So basically turn, well, scan the key matrix, turn, well, generate a bitmap of keys down. I think I actually should say that these are in the opposite order, because the whoa. That was paste instead of copy. It's actually the other way around. First we want to scan, actually I should just... First we want to scan the key matrix and generate a bitmap of keys down. While we're doing this, we want to do debouncing. Right? And then second, I think what I want to do is compare with a previous state, with previous bitmap, to detect which keys are newly pressed or released. And then after that, oh, actually, hold on. Before we do that, we want to combine bitmaps of both keyboard sides. So right now I'm kind of doing all this together in a kind of a mishmash way, but I want to separate them. So I want to do the scanning first, including the debouncing, and then I want to combine both sides. And then with the combined keyboard key bitmaps, I want to see how it's different. Probably just by doing an exclusive OR, I guess would tell us that, right? Exclusive OR of the previous and the next bitmap would tell us which keys are newly pressed or released, right? And then from that we can, I guess, perform, well, handle mod tap, right? So basically, detect when we should determine, really, not detect. Determine, this is for each key newly pressed. Determine if it... but basically determine what action. Let me combine this. For each key pressed, determine what action to take. So there's possible actions are to add a key code to the HID report to the host, right? Another one might be change modifiers. Another one might be a start tapping term for a mod tap. Okay, and then actually this is broken into two pieces, right? Ah. And these are just bullets. Okay. For each key newly released, determine what action to take. So, we might remove key code from the HID report. We might again change modifiers. Actually, I thought of another thing here. We might want to start tapping term also freezes modifiers, right? Freeze modifiers. Changing modifiers might we might want to unfreeze modifiers at this point. If you guys hear yelling and screaming in the background, it's because my family's pretty loud. All right. There's probably another thing here I'm just not remembering. In the end, though, we want to compare HID. How come I can't spell this right? With last one sent to host. If different, this should just be a bullet item. Send it. Send the new one to the host. I think this is the order in which I want to do things. I should say here, handle debouncing, or debounce. Do you use a guide for building this keyboard? I use some inspiration, so for example, the corn keyboard I have. I'm using, that's what I'm typing on right now, this guy. So you can see there's a bit of resemblance between the corn keyboard I have and, you know, this is the shape and form that my keyboard is going to have. Oh, that's another thing I forgot to mention. I designed this over the weekend. The plate that's going to hold the switches. So this is the bottommost like chassis piece, 3D printed, right? And it's got these nickel inserts for screws. The PCB goes on top. The PCB goes on top of that, and then on top of the PCB goes the switch plate. And then the switches fit in all of these holes, right? And then these 4 screw holes are what hold everything together. So I did that over the weekend, and you'll see a strong resemblance between, you know, this and the corn keyboard I have. So if there's any kind of guide, it was this corn keyboard. I looked at its PCB design, since it's all open source. I also took the right-hand one apart. I disassembled it to see how it was constructed, and that was sort of my guide. Like what I learned from looking at disassembling it was my guide on several things, including how to secure the screws. So these are just 3D printed standoffs with little nickel screw inserts in there, and it's the same thing that the corn keyboard uses. Hey there, Stripe Monkey. How are you doing? So yeah, that was my little show and tell of the day. I guess I could put this off to the side now. Other than that, I'm not really using any kind of guide. Well, okay, the connectors to go between the two keyboards, I got inspiration from reading Reddit and other things, searching online for that. So on the prototype here, I had both the TRRS, this audio connector, and this USB-C connector. So if I bring it closer to the camera, you'll see. One's an audio connector, one's a USB-C. From this proto board, I can connect either way, and I settled on USB-C because as long as I can get it soldered correctly, it's kind of a nicer connection because I can do something like this and not worry about shorting the power to ground. Whereas with the audio connector, you have power and ground sliding past each other potentially, and they can cause problems, right? You're not supposed to unplug it while it's electrically connected. So yeah, other than like examples and other boards and what people have said on posts, I really don't have any other kind of guide. So yeah, I wanted to show that at some point in the stream, so might as well do it now. So like the work I'm going to do today, this isn't following any kind of guide. It just seems to me a step-by-step procedure for turning like the electrical connection detection to a keyboard report. It just seems the logical way to do it, but I could be wrong. I have to watch my YouTube videos to catch up. Yeah, I'm 21 videos in. What I was thinking about doing, because I know people hate catching up by watching hours and hours of stuff, is I might make a YouTube video that's kind of like the highlights. Basically, extract bits of each video and maybe talk over it and say, oh, at this point I was doing this, and then I did this, and make that maybe I don't know, 15 to 30 minutes long, and release that as a standalone video, so you don't have to watch all of my videos. If you're willing to wait for me to make the recap, probably after I'm done with the series, then that's probably a better thing to watch to get caught up. And then if there's anything like you're really curious about in the details, you can go to the matching video for that. That's what I would do if I were you. All right, so let's start on number one. Let's just have it do the scanning and generate a bitmap, and then we'll do debouncing. So debouncing is basically pretty simple. If I use zeros and ones to indicate like whether a key is detected to be pressed or not, 0 being no and 1 being yes, we're going to see a lot of zeros for a long time until I actually hit the key, right? At some point we'll see a 1, and the two ways that we're going to expect the debouncing is we might have a couple ones and then a few zeros, and then a bunch of ones, and then it stays solid. We might actually see another 0 here. And so this region of time is where the signal is unstable. So what I was planning to do is whenever we see a 1, we'll start a countdown. And if we see a 0 before we count down is done, then we'll say, well, let's just ignore that. So this would be, okay, start counting, okay, stop counting, because that was a spurious, right? And then start counting again, and then up, stop counting, and then start counting again. And let's say we only need to count to 6, right? We see 1, 2, 3, 4, 5, 6, and there's like, okay, now the key is held down. So this would be debounced as this, right? No, 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 and then yes, 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 right? And then let's say it goes back to 0. You'd see that, right? So there's a little bit of delay here, right? If I actually press the key at this point, but we don't call it a key press until here, there's that many samples of delay. But my keyboard is telling me I'm anywhere from 10,000 to 40,000 samples per second. This is going to be an extremely short amount of time, like we're talking like less than a millisecond. So I think it's fine. So I'm just going to do a very crude debouncing logic where we just have a countdown. Maybe it's like 5 or 10, and we have to see the key held down consecutively that many times before we say, yes, now the key is held down. Probably do the same thing for key release. Once a key is held down, to actually call it released, we would have to see a bunch of zeros in order. So let's say we had like a spurious 0 there, and it stayed a 1, and then finally it went to 0. We would say, okay, no, that's actually still held down. and then still held down a few more times, and then okay, now it's released. So we would have some kind, we'll have it in both directions. I think that's fair. You're building keyboards, so trying to learn as much as possible. So depending on what step in the process I'm doing, I'm either going to be doing some of the firmware, so the software loaded in the microcontroller here, or I might be doing hardware design, or I might be doing modeling. You've missed all of the hardware design, I hope. And I'm just finishing up the firmware coding. So the past videos you find on my YouTube will be a mix of those. If you want to see me designing the circuit board, I forget which video that was, like around 17 or 18. And now today I'm focusing on logic. Do the key switches have anything in them for debouncing already? Sort of, like these mechanical, these Cherry MX switches. They have like mechanical parts inside that, well, number one, like the really clicky ones actually click when you push them past a certain point. But yeah, they're kind of designed where there's a critical point where it goes from off to on, and that lessens the bouncing. But what I've seen experimentally is there's still some electrical bouncing. So there's physical bouncing where you actually might, when you pass the point from going from a 0 to 1, it might actually vibrate slightly, like right on that edge, and you might see something like this. But there's also just electrical bouncing where the signal is just not exactly square, but it's more of like there's some ringing in it. And depending on how bad the ringing is, it could be detected as a 0 where it should have been a 1, right? So both kinds of ringing, both kinds of bouncing, so to speak, can happen, and we want to try to eliminate both. And these switches, although they're mechanically making it less likely to bounce, there's still some bouncing that we see. It's probably not as bad as if it was a plain, like simple plunger and plate up underneath it. Okay, so this was just to illustrate. I don't think I actually need it in my notes. Yeah, let's do the debouncing first. I'm basically going to rip all this code out, right? We want to keep the base around for now. Keeping that. This register key, right? Yeah, I think I want to redo all this stuff. Yeah, so I think this is the way I want to do it. I want to have like a let keys mutable equals 0. And then let's just have like a actually let's I'm bad with names here. Hi there, Willy Wonka. These are like key states. Key state? How about matrix state? The state of the matrix. Key state. And then I want to have like a constant keys. And this will be an array. Because what I want to represent are the things that are varying here. So like which row goes with which key index, right? And I guess which column. Yeah, so let's have like tuple here, and we'll have Actually, I can't put these in any kind of collection, right? Because they're different types. Yeah. But what I can do is I can have the number part and then end up doing a match later. Okay, so let's just have the column number, and then in a secondary tuple, well, not a tuple, an array, we would have like the row number and which key that is. So column 0, row 0 is bit 0. And then row 1 would... Actually, I don't even need to do this. I can just do it with math, right? It's the column number times the number of rows. No, the other way around. It's the row number times the number of columns plus the column number. Yeah, okay, so I don't need any of this. Okay. Okay, that means I really only need to have some constants. Like dimensions of our key matrix. So const num rows. Gee, what type should I use? U32? 3. It'll soon change. Actually, rows will always be 3. Number of columns is going to be changed. Right now we only have 2 columns, and the final board will have 6. Right? So this would be like for column in 0 to num columns, and then for row in 0 to num rows. Okay. So you know what I'm going to do is I'm going to end up having a function that sets something high or low depending on which column number it is. So yeah, it'll be removing. Why don't I just put it in here? So like self dot drive column. Column, and then the state, right? So I should have just an enum for this rather than using the Boolean type. So pin, actually I wonder if I could, can I like use a type in here somewhere? They don't use enums for this stuff. Yeah, never mind. I'll just make my own. Pin drive states. Actually, why don't I even have a comment? This is just going to be a type, right? Enum. Pin state. High. Let's just call it low and high. Keeping them in order, alphabetical order there. Okay, so then this would be a pin state low. And at the end, we're going to drive it high again, right? Like that. And in between, actually, that goes here and that goes there. this is actually what that does. So let's actually make that function now. Function drive column. So it's column, which is U32, and then it's state is a pin state. All right, and then here's where I got to do the match on the column. This guy, right? Actually, they're all going to do unwrap, so I can just do unwrap at the end, right? Okay. So there are only 2 columns right now. So then I'll make this one unreachable. Okay. Oh, I guess it does depend on the state to match state. What? Oh, I need to have match arms. Pin state, high and low. Actually, it's just gonna be this, but set high, right? Low, and then these are all highs. Okay. Is this going to tell me it needs mutable access? Yeah, okay, so mutable. Cool. So then that simplifies the drive column. I don't need this. Okay. So then while we're driving the column low, we're going to scan the rows. So that's self dots. Yeah, this one's. Oh, did I make that? Oh, I did make that generic. So then that's a match, right? Let's just do this. Actually, there's only 2 rows right now. And this is unreachable. So let is down equal that. Okay, and then actually I don't even need the, well, let's make it easier to read. We'll just do this. If it's down, then I want key state to be ORed equal with 1 shifted left, and here's where we're calculating which key number it is, right? It's going to be the column number plus the row number times the number of columns. Right? So that does all this stuff and all this stuff. So that should reduce our key state. Oh, I guess it's telling me I don't need these extra parentheses. So now at the end, the key state will be like a bitmap of all the keys that are pressed down. So this is scan all keys to form a bitmap of all keys detected to be down. All right. So back to my little plan here. Then we need to debounce them, which means I'll need to like remember which ones were held down before. And I guess what we'll do is I'm thinking actually for each key needs to be independently debounced, right? So we're talking like about a map between a key and a counter, I guess. Actually, we're debouncing. We're ignoring it we're ignoring every kind of transition, right? So we need to remember its previous state. You know, it means I can do the debouncing here. Now that I think about it. I can do it right here, actually. So this is detective key is down. And then we'll do the debouncing. Perform debouncing. And then if, well, incorporate debounced key state into final bitmap. Okay, that means I'm gonna want to have like key transition state. I'm really bad with names. It's gonna be like key something, right? Key. How about key last transition? I like that. Okay, so key last transition. We're going to just record a counter. Yeah, because I'll also have a bitmap of the last keys, right? I would just call it key bounce counters. So whenever we detect a transition or a key going from 0 to 1 or 1 to 0, we're going to add a counter for it. And then every time we scan, we're decrementing these counters. And if a counter ever reaches 0, then we accept the transition, right? That means I'll also have to remember, yeah, I'll also have to remember what its previous state was. Yeah, okay, I got it. So this is going to be a B tree map. U8 is the key index, and then actually, yeah, that means up here when I do these should be U8s. I'll never have more than 256 rows or columns. Actually, I never have more than 15 of either, so it should never overflow a U8. Okay, where was I? Where was I? I was right here. Should I use a scan counter, or should I use a absolute time from the timer? I think I'd actually feel more comfortable if I use a timer. Because then it's not dependent on how fast we're scanning, right? Okay, so it's not counters anymore, it's key transition times. There we go. Key transition times. So many choices, I know. Names are hard. Don't you agree? And I have a lot of state in this structure, and so names are doubly important, because not only does it help me reading the code, but also to distinguish which thing from the structure I need to be using. Okay, so there we go. Okay, we need to fix this to be a U8 again. All right. Yes. So let's move this now thing up to here, because we're just going to sample the timer at this point, right? This drive... Oh, you know what? This delay, we really need to do that when we're... Actually, we need to do it if we're driving high or low, right? Actually, I think I only really care about delaying on after driving low. So what if I move this delay out? And I put it down here where we're scanning. Where was it? Losing track of where I am. Right here. This is to let the signals settle. We don't need to do it when we drive it high, because usually we're going to drive the previous column high only to loop back and drive the next column low, and then we're doing our settle delay here. Looks like decoding raw keyboard. Yep, this is our test keyboard. I'm printing a larger one that has 18 keys on each side, so 36 total. But that PCB won't arrive until Friday, so I'm still on this intermediate prototype. But this is fine. We got 2 whole columns and 3 whole rows to play with. But yeah, I'm ripping out the old like experimental logic and implementing this logic. So scanning the key matrix, generating a bitmap of the keys, and we're doing debouncing while we're doing that. And then after we do that, the next step I'll get to is got to combine the 2 halves together to merge them. Then compare with the previous to see which ones are actually newly pressed and which ones are newly released. And then we'll handle the mod tap logic. And then if this is to generate, we're adding and removing keys from a human interface device report. And we send that over USB to the host if it changes. So that's what I'm working on right now. You actually go overly descriptive with your names. Auto-completion makes it... Yeah, that's true. I get people poke fun at me sometimes for having extremely long names, especially in my last project where I would have some names that were like, for especially tests, they're like 20, 30 characters long. Because I wanted the test's name to describe fully what the test is doing. Okay, so perform debouncing. Oh, I need to have prepared the previous key state. So we have this previous report. Let's have a previous key state. And this is the local key state, right? The debounce is going to be performed locally on each half. So I really only need a U32. Right? Okay. And that will start where we'll assume that all the keys no keys are pressed when it resets, which is probably fine, because if someone is holding in a key on reset, it'll just look like an immediate press, right, on reset. So it's just a 0 to start with. What's the host? A host is any kind of operating system, anything that can talk to a USB keyboard. So this USB connector, it's going to my Windows machine, but I also want it to work on Linux and Mac at least. Anything that supports the USB human interface device class. So it's basically defined by the USB standards. And I'm using a crate that handles it for me. It's, I think, literally called USB-D HID, right? It's the HID, Human Interface Device Report Descriptor Generation, and USB HID class implementation. So anything that can talk to the standard USB HID class. Yeah, USB, yeah. But all the USB stuff is handled for me. Fortunate enough that some nice people in the open source community have already written Rust crates for that. along with the USB device stack and everything. I'm just writing basically the peripheral implementation and reusing those common libraries. Okay, so down. Right, previous key state. We're looking at that, right? I get lost in my own code. Scan keys, right? Okay, perform debouncing. So what are we doing here? So I said that if it's two possibilities, right? Either the state is unchanged from the last state. If so, then we need to see if there's a transition time in the map. Then we want to remove it because basically that was a bounce. Right. So if actually we're going to use the entry no matter what, right? So let's just do a match on self dot key transition times dot entry, and the entry is going to be the key number. Oh, we should just compute that here. So let key, just key, I guess, right? Or key index is a better name. Okay, so key index. Fill match arms. So I can shorten this to just vtree map, I think. We can just import that directly. Okay. So it's either vacant or occupied, right? So if it is occupied, let's do occupied first. Then it depends on if the state has changed or not. Actually, let's figure that out here. Detect if the key state changed. Actually, I think I just realized I need to have both a raw and a cooked previous key state. So let's make that cooked. Cooked as in debounced. Actually, why don't we just call it debounced? Debounced and raw. I think I need to have both of them before and after debouncing for what I'm about to do. So let's just do that. Debounced. And, oops. And raw. Debouncing just removes the jitter from the physical connection? Yeah. So I had it in my notebook before, but I could do it again. I should just keep it this time, right? Actually, if I undo here, there we go. So imagine that this is the input. Actually, that looks pretty good. Let me collapse that so you can see better. So if 0 is like not pressed and 1 is pressed, what I want it to do is kind of ignore when it's transitioning wildly. So it like keeps the previous debounced state, right? And then, but when it sees enough ones in a row, it says, okay, that key is definitely pressed. So then we would transition to it pressed. And then we would ignore these like spurious zeros. Right? So it stays at 1 even though it went to 0 because the following, it followed with a bunch of 1s, right? But then if we see enough zeros in a row, we go back to 0 again and then it repeats. So there's a little bit of delay, but if we're sampling very high frequency, like 50 microseconds per sample, then this is hardly any time at all. You won't even notice, like less than a millisecond. So it'll be maybe a less than a millisecond lag in key press and release at the benefit of completely debouncing it. So we won't see like a whole bunch of key press release like within a few microseconds. It'd be nice and smooth. So that's what I'm trying to do. Okay. I mean, it's basically four combinations to deal with, right? We either have a 0 to 1 transition when we're at 0, or we have a 0 to 1 transition when we were at a 1, or we have a 0 to 0 when we were at a 0, or we have a 1 to 1 when we were at a 0. And then like this 1 1 from a 0 stays at 0, but this 1 1 goes to a 1 because we had enough ones beforehand. So there's going to be like logic depending on how long, when was this first 0 to 1. This is where we're going to sample the time and put it into our map. And at this point we're going to say, okay, the time has been large enough that it really is a transition. But if we see like this 1 to 1, it won't be a long enough time, and so we won't transition. And then if we see a 1 back to a 0, then I think we throw it out of our map so that when we actually, maybe it doesn't matter, because the moment we see the 0 to 1, we're going to put it back into our map and replace it if it was there, right? Yeah, okay. Yeah, I think I know what to do. This is hard. Detect a key currently held down. Detected the key state changed. Since the last sampling. So that would be a changed is if we take that self dot previous key state raw, and then we want to OR it with the inverse. Actually, I think in Rust you just use exclamation mark of actually we can just make it here like key mask, right? Is oh, that is the key mask. Okay, so yeah. Well, this is just one shifted left key index. And the key index is just this. There. So it's key mask, right? So can we just say there's an OR mask and an AND mask? Just form both of them. Whoops. Not key or mask. Okay, then I can just say key and mask. Well, let's divide this again into two variables. One is let was down equal to this in parentheses not equal to 0, right? Smell a fun state machine? Hey there, Metro. Not really a state machine. It's more of a... Well, I guess you could think of it as a state machine. It's not a really big state machine, though. There are really only 3 states. It's either not pressed at all, pressed, or it's... actually, there are 4. Maybe pressed and maybe released. There's 4 states. Just a small one, yeah. Was down, changed. So changed would be that is down is not equal to was down. Right? Let me make sure the scan key is correct. If the row is low, then it's down. It was down if the previous raw ended with the key and mask. So masking out any other key is not equal to 0, then it was down. 1 means down. Okay, change this if is down is not equal to was down. Right. So if there's something in the key transition times, and then it depends on if the actual key was changed, right? If changed, yeah, if it changed, then we want to reset the entry, right? So entry get mute equal to now. It gives me mutable, so I have to dereference it. I can't do this? Probably because why? This is not mutable? There we go. Hey there, Pollux. How are you doing? Do you release the game? No. I have to put the game on hold because I got a job, and the job doesn't allow me to do open source right now. So I'm doing non-open source projects right now. Technically, I could still work on the game, but I can't open source it. So, but I wanted to, so, or I wanted to make it available online, right? So I'm holding off until I can do that again. I should probably comment this as I'm going. Key, well, the key may be transitioning. If it just changed, reset the transition time, right? If it didn't change, we want to declare the key actually transitioned once if enough time has elapsed. Do whatever you want with it, right? It's a condition of employment that I follow all their company policies, and one company policy is that to participate in open source, you have to get permission, and then I haven't gotten that permission. They actually said, no, it can't work on games or open source. Unless I have to go through a process to get okay doing open source. I even had, just to make sure, I went through one of the processes to make sure I could stream, and they said it's fine as long as I don't talk about, it's not related to my work, and I don't like talk about like work stuff. So that's why I avoid it. Because some companies restrict what you can do in your time. Well, it's at will employment, so they say, well, we'll employ you if you agree to these policies, and then you're free to say no, and then you're no longer employed there. So I appreciate being employed there and the money that they give me in exchange for the work I do. So I'm willing to accept their terms for now. But if I really wanted to work on my game again, and it was so important to me that I'd rather get another job or quit, I would do it. Right now, I'm happy right now putting the game on hold and doing other things. Okay, so we need this else, right? Else if now minus the entry is greater than or equal to some kind of constant we need to define, like debounce time. Then we have then we actually have a transition that happened, and the state will be the let me think about this. Yeah, the state will be whatever the state is now, right? So then we want to do two things. I want to remove the entry, so entry dot remove, and we want to actually set it in the debounced state, right? Actually, it's not previous, is it? No, there is a right. Okay, so I need a new and a previous. Shoot, this is hard. Okay, that means actually it's key state, isn't it? Yeah, key state's what we want to put it in. Right, so key state, if is down. Actually, then I want to initialize this. Key state should be equal to self dot previous key state debounced. Because we're updating it, and then we're going to see if anything changed. And those that changed, yeah, we'll know what to do with. Let's declare this before I get too far ahead of myself. U64. I don't know. How about a millisecond? Not even that. Well, let's just keep it at a millisecond right now. Yeah, process of elimination, you probably already know a lot of the companies I don't work for because you probably know that they don't have any policies that require you to get permission for those things. But I really shouldn't, like, let it... Yeah, let's just not talk about it. I don't want to have to stop streaming. Okay, cannot be dereferenced, why not? Oh, I have to do get. I probably don't even need to do that because we're not storing in it, right? It doesn't automatically deref. Right, so if it... Actually, if we know that there was something in there, then we can just flip the bit, right? We don't even need to say if down. So we just see a key state XOR. Which one is that? XOR equal key or mask. Right? Just invert the bit. Okay. Then we have entry here as well. So vacant means that we haven't detected a transition yet. So here's where we need to say, is there a transition? If changed, then don't I just put this in right here, and that's all I need to do? Let me think about this. I think so. Oh, and we can't do that. It's different, right? It's entry dot insert now. And we don't need to mutate the entry, right? Where are you getting debounce time? Should it vary? It's just a arbitrary constant in microseconds. Let's rename that. It's just something that I'm making up, like, in this theoretical sequence, like, how long are we going to have an unstable line before it stabilizes if we're actually hitting the key, right? And I'm guessing just a millisecond. It's probably way more conservative. We can play around with this to see. I can reduce this number until I start to see actual bounces, and then we can double it and call it a day. So I'm just starting with some number. If we see bounces, we'll double it. If we don't see it, we'll cut it in half until we see it go from happening to not happening, or vice versa, and then we'll move it off of that boundary. That's like the scientific process that I think I want to follow. Row 2 is not used? Wait, did I miss something? Did I not scan row 2? Oh, I didn't scan row 2. Warnings to the rescue. Is this all I need to do? So if there's no entry in our key transition time, that means we haven't seen a state change. We're stable, and if we see it change, we immediately insert the current time. So the next time we come through here, if there's something in here but it didn't change, oh, I didn't have an else here. Let's say it didn't change. Oh yeah, then we don't do anything. So the first 0 to 1 it'll be vacant. We insert the current time. Then there are two possibilities after that. We see it go back to 0 again, which would be occupied, and it did change. So actually, this isn't correct. Then there are two possibilities in here. Let me not comment this yet. I'll comment it when I have a clear idea of what's going on. There are two possibilities if it changed just now. It either went back to the stable state, in which case we're going to remove the entry, or we actually, that is the only possibility, right? Yeah. Don't I just always remove it? No, I don't remove it in the else, which we don't have. Okay, this is correct then. So then we don't need to mutate that entry. Okay, so looking at our test case here, 0 to 0 is no change. So that means it's always vacant, it's no change, so nothing happens. 0 to 1 it's vacant and it changed, so insert the current time. Right? Then we see a 1, 1, which is no change, but it's occupied. So that goes into here and it tests this. And this is false, so it doesn't do anything, right? Right? And then we see 1 to 0, which is it's occupied. It did change though. So then we remove our entry, right? So basically we ignored the 1, 1 because we never saw it stay occupied with no change long enough to trigger the key state change. So then we continue until we get to this state where there's no change, but it's occupied, it's been occupied for long enough. We would remove it and then we'd flip the state. So now we flip the state and then everything is sort of inverted from there, right? A 1 to 0 causes it to sample it again, and then a 0 back to a 1 removes it. And then when it goes to 0 long enough, it flips it again. I think this will work. So then I don't need to do this. So key state ends up having the new debounce state, really, at the end here. Okay, so that's detect which keys actually change state. Well, really, it's update debounced key state. I think to start with in the debugging, we're just going to print if it ever changes. So if key state is not equal to a self dot previous, how come it's not letting me do this? Previous key state debounced. Then we're going to do info. Keys debounced. We'll print :0. How many are there? There are 6. 6. Is there a B for binary? I need to look that up. It'd be great if it was binary, so then we can easily debug it, right? And then we want to just update this. You write code all day, it's been fun, but you're gonna watch some hot tub boob streams. Okay, nice to meet you, David Delon. Enjoy your hot tub boob streams. Is that all you guys look at is boobs? That's okay, I won't talk more about it. Probably get myself in trouble. Alright, I'm gonna remove this stuff, right? For now. Yeah, let's remove this stuff. Let's not report any key codes. So let's just drop all this stuff. I want to report the raw key state. So where do I capture that? Looks like I don't, so I should do that. Let's rename this one to key state debounced. And then we'll have a key state raw. And then what I'll do is, I guess I'll just add it here. If is down, then key state raw, or equal key or mask. Unsafe. Yeah, unsafe to talk about that. Safe code, but not unsafe, or not safe discussion. Maybe you're a boob. Maybe. Yeah, we can just duplicate this code, right? If key state raw. So let's actually just repeat all the raw here. So if the raw key state, if the raw key state changed, we're going to log it, and we're also going to store it and debounce as well. And that's all I'm going to do. So I'm going to remove this stuff here. What is that? Oh, right. When do we want to report this? I guess we can report that at any time, right? So let's just grab this and put it in the debounced, I guess. And include that here. Samples per second. All right, and then I'm gonna drop this stuff. I want to keep this code though. We're gonna have to do this, but not right now. So I'm gonna put it there, but I'm gonna comment it out. And I can just drop all this stuff. We don't need to. We're not gonna send a keyboard report either. I'm gonna get rid of that stuff. Okay. This is just a test, so my keyboard won't actually send anything back to the host yet, because we're just trying to handle the first step. Learning with HTML, this is a little bit hard, but you're trying. Good for you. I'm not doing HTML, I'm doing something completely different, but that's fine. Let's see if this builds. HTML, I've heard, is Turing complete, so it is a programming language. And who was it? The Primogen the other day was streaming HTML as a language, and I kind of regret not watching that stream. Language? This is Rust. Alright, let's just try to program it. Oh, I can show you guys the updated programmer. It's got a GUI now because I intend to put programming widgets in here. Right now it's just showing the log like it was before, but it's in its own dedicated window. Okay, so let's press some keys. And nothing happened. Is it printing anything at all? Yes. Oh, wait. Well, that was weird. It's taking me actually logging something else? Why would that matter? Am I missing like character turn line feed? Hold on. Why would these infos not get through? Until I do that. Why does that matter? Okay, that's really odd. What I'm doing is I'm turning caps lock on and off. And it's not logging anything until caps lock goes on. Why would that be? I wonder if it has to do something to do with these. Why would it matter if I did a B there or not? Let's put in something more predictable. Maybe I'm doing something bad there. Who knows? I have to quit this guy. Why would that matter? Programming. Oh, wait. I think I might know why. I think it might be not servicing the... It might be busy waiting in there. Hold on. Think about this. No, it shouldn't matter. Okay. But it seems to matter. Why is this? Okay, this is strange. Why would it... What did I change to make it where it doesn't log right away? And why would it matter if I hit caps lock or not? So that's down here? Why would it matter if we hit this line or not? Right, that does that. And that just reports it inside of scan keys. Why does that matter? See, it's not updating this log right now. You're learning Python too? That's great. Okay, so there's it's messages generated, right? So if I hit it again and I do this, the log messages did advance by about 7 seconds, right? Okay, anyway, one thing at a time. Does this look correct? Raw 1, raw 0. Debounced 1? Debounced all ones? What? That's not right. What did I do there? Okay. If I press and then release, what do I see? Press and then a little bit later release, but no debounce time. Why? Key state raw. Previous key state raw would have been recorded. I don't get it. What did I do wrong? Oh no. It's 2 and that's 3, right? What did I do wrong? I messed something up. Key index is going to be at most, what is that? 2 times 2, 4. So it'll be 0 to 5, right? I mean, that's fine. This now is going to be sampled from the timer. I don't get it. What did I do wrong here? A couple things I don't understand, actually. Why does debounce go from that to all ones all of a sudden? All ones. What does that tell me? I don't understand. I don't see this. Self previous state debounced. That's down. That's updated down here. Previous debounced is current debounced if they're not equal. Okay, there's something fundamentally wrong with that. And I don't understand it. That's only 300 microseconds later, so it's probably the very next scan it sees all ones somehow. Why would it see all ones? That's if we kept going into this one. Is this the problem? This key index maybe is wrong? Key index is column plus row times number of columns. I'm thinking that's a U8. They're all U8s, right? But this should not overflow. So U32, that's also a U32. What is it? What am I missing? Wait, I also didn't see debounced state change. Oh, wait. Only the very first time do we see that happen. No? Hold on. I don't understand what I'm seeing. 1, 2, 3, 4, 5. One, two, three, four, five. 1, and then it goes to that, and then 0. 2, and then it goes back to 1. 3, 4. I really don't understand what I'm seeing. So if I continue to hit this, I won't ever see debounce state changed? No, I'm seeing it randomly happen. don't understand. Just sometimes it swaps all those bits and sometimes it doesn't. Should be row times number of rows. No. Why would it be number? Why? Columns times number of rows? It's row times number of columns. If you're on the 0th row, you don't add any to the key. Yeah, it should be 0. Row 0, column 0 is 0, right? And then row 0, column 1 is 1. Row 1, column 0 is 2. Row 1, column 1 is 3. It's because I numbered them in this way, right? If this is column 0, column 1, row 0, row 1, row 2, then this is 0, 1, 2, 3, 4, and 5. I don't think there's a problem with the mask, because if I like go through all the keys like that, and then we actually see the bit pattern walk through, right? I'm hitting all the keys. It's just that the debounce state is wrong. So the raw state's correct, right? So if I like, let's say if I hold down, so I just rolled through it. Then we saw 1, 1, 1, 1, 0, 0, 0. That's correct, right? It's just the debouncing state is completely wrong. One, 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 one. Yeah, that's correct. Okay, so the raw state's correct. It's just the debounce state is completely wrong. So there's something wrong with this. This is correct. This is wrong. And we also have the unrelated, possibly unrelated problem where logging isn't happening correctly. So something to do with this key transition times. Something related to this. Type of this is B tree map from U8 to U64. Gets the given keys corresponding entry in the map for in-place manipulation. It's not gonna actually insert unless I call insert, right? Oh, good night, Nightshade, dude. It is getting late. It's 11 o'clock for me. It was down. Maybe there's something wrong with was down. If previous key state raw and key and mask. Oh, it should be or mask. That's the problem. We only want to select one of the bits and out all the rest. Okay, that's what it was. We don't need this and mask then. Great. Okay. It's always something subtle, right? I am glad that I'm debugging these things one step at a time rather than like trying to debug them all together. That'd be a pain. Okay. Okay, cool. So let's press it really fast twice. It actually detected it. It would be nice if I could fix the log so I don't have to keep turning caps lock on and off. Oh, wait. I think I know what's going on. We're not actually processing the USB for some reason because... Yeah, that's what it is. Okay, I know what it is. We're not seeing the log messages come through because we're not going into the code in USB that says to try to write something. Yeah, I remember this code now. So that must be a bug that we never saw in poll USB. Because we don't try to send the log to the host. Where do we do that, actually? I actually don't even see where we do it. Would using the new type pattern here help catch at compile time? The new type? You mean instead of using a bit mask? Well, the problem is not type related. It was I had the wrong mask. I'm not sure how a new type pattern there would fix it. That's okay. But you might be right and I'm just not seeing it. Curious what the log issue is? Yeah, so the log has to go through the USB device, right? And the way the USB device works is the host is pinging us, and on our side we poll the device to see if we got anything. But the thing is, I'm never trying to write unless we got something from the host, and we're not going to get something from the host right now unless we actually either are... I guess it's this. We were always doing that every time before. Now we're not. We're not doing this at all. And this is happening if I hit the caps lock key on, right? So I think it's that we're not getting into this for some reason. Or maybe it's just that we're not... the poll isn't returning true. Well, let's see what poll says. Polls USB bus for new events and dispatches into the provided classes. Returns true if one of the classes may have data available for reading or be ready for writing, false otherwise. Should be called periodically as often as possible for the best data rate. Must be called at least once every 10 milliseconds while connected. List of classes must be in the same order. Strictly speaking, list of classes is allowed to change. Okay. So it's called if there's data available for reading or ready for writing. We should be configured. We should have data ready to write, but we're not writing it. Why not? Because we're not getting... poll is not returning true? Why would that be? Okay, well, I think to temporarily unblock this, I suspect it's because we're not actually doing the sending something to the host. So let's just send always zeros. Where was the code that did that? I commented it out, right? This one right here. Let's just always do this. And this key code, since we never touched it, it's just going to be always 0. That should at least unblock me on the log. And I'll figure out what I'm doing. I must be misunderstanding something about the USB device. That's my guess. So we're just going to be constantly writing an empty key report to the host. I bet this will unblock me, actually. Let's see. Yeah, see, now the log is always getting through. Okay, so let's see if I can get it to bounce. Basically, I have to keep pressing and releasing until I see a bounce. Look how fast it's scanning, though. 78,000 times per second. Oh, we saw a bounce there. Right? We saw it transition to a 1 and then immediately back to a 0, and it didn't trigger an extra press. So it debounced it correctly, right? It was at 0, it saw a 1, and then immediately went back to a 0, and so it didn't trigger a key press. And see, let's move to another key. Oh, saw a bounce. Look at that. So I was holding down the 3rd key, and then it saw the 4th key go down, but then go back up immediately, and then go back down, and then it stayed down long enough to where we detected it. And then 300 milliseconds later, we released the other key, and it stayed released, and then I finally released the last key, and it got released. There we go. So it's like a keyboard driver sort of thing. Yeah. So what I'm doing here is I am interpreting the electrical signals on the keyboard and turning them into indicators back to the computer about whether or not we're actually holding a key down. Debouncing is taking care of conditions like this where we had a zero like spuriously instead of a long string of zeros and then a long string of ones. We actually have these like extra zeros in the middle where there's ones, and we have well, however, you might see these as like spurious ones, or you might see, and this is a spurious zero, or the other way around. These could be spurious ones there and there, right? So it's where the electrical signal is not stable yet. We're transitioning between it not being pressed and pressing it. We have this instability here. So the debouncing algorithm is just ignoring that and waiting until it sees a constant string of ones and then says, okay, so you must be pressing the button now because we're seeing it stable at a 1. And then here, like, this is an unstable, like a spurious zero. This shouldn't be there. And then we see a consistent set of zeros. It's like, okay, you must have released it. So that's what the code here is doing, that it's at all zeros, and then it sees one of them go to 1, and then it sees it go to 0, and then it sees it go to 1, and then it stays at a 1 long enough to says, okay, we've debounced it to a 1. So I'm happy with this. I want to see if I see any more bounces that get debounced. It's easy to see because it'll break the pattern of raw debounced, right? If we actually see a bounce somewhere in here. The right-hand side still work, yeah. So on the brown switches, I'm not getting any bounces. So what if I hold the switch right on the edge of being on or off? It's hard to do with the white switch, actually, because it... Yeah, maybe it's easier with the brown switch. Nope. I mean, it's pretty consistent. Yep. I'm not getting any bounces right now. Like the voltage is somewhere between false and true. Yeah, pretty much. It's kind of like when like you're closing a switch and you're right at that moment where there's still a little bit of an air gap, and then you can get a spark across there. You'll get a lot of noise on the signal, and the analog to digital converter is going to be like sometimes confused, right? You won't get a nice square like consistent 0 to consistent 1. You'll have a little bit of up and down right at that boundary. I'm not seeing it right now, but we're only sampling at 78,000 times per second. So we're probably not catching a lot of them, right? Oh, there, one happened right there. So you can see it in the timestamps. The timestamps are all really close together. 0.677, 0.678, 0.678. So within a millisecond, we saw it go on, off, and then on again. And then it stayed on long enough to where after a full millisecond after that, it was still on and never went off, that we say, okay, it must be held down. So cool, my debouncing works. On to the next step. Actually, I should check this code in, right? Well, let's clean up the warnings first. I'm not going to clean up actually those warnings. We're going to remove these functions we don't actually need anymore. Yeah, this register key up, this is all... Actually, I don't know if I should delete all this stuff because I'm going to have to read... I'll have to rewrite some of it. That's okay. We'll get rid of it all. We're using scan key, right? We're just not using register key down anymore. Okay. I will use these in the future. How about we just comment them out because we don't need them, and let's take that immutable for now. Yeah, let's remove these. Wait a minute, I didn't use that? Hold on, it said I didn't use the previous key debounced for some reason. Maybe I misread that. Oh, previous report and pending keys, yeah. And simulated keys. And active keys, yeah. Okay, those we aren't gonna need, probably. Simulated keys, okay. Previous report. Might need that. I'm gonna keep that around for now. Actually, how about if I just commented? Nah, that's okay. I'll add it back. Adding back is easy, right? And didn't need the B tree set. Okay. Just cleaning up the code so no warnings or errors. What's the base repo for your keyboard code? It's a private repo. I can't open source this yet, so it's not public. Okay, let's close this. So we're gonna commit, and we're gonna say work in progress. Rewriting key, what's the name of the stream? Key state handling? I'll just copy from my own stream title. So, remove all the old key state handling. And then add new key matrix scanning. Add debouncing logic. Nope, not using QMK or ZMK. This is all, well, not completely written from scratch. What it's based on are the Adafruit KB2040, because that's the board I'm using. Do the command there. I'm using that particular controller board, this pink board here, and that's based off of the Raspberry Pi 2040, which is Raspberry Pi's first microcontroller. So I'm using a lot of the things that come with that board support package, including all of their hardware abstraction layer, peripheral access crate, and all that stuff. And I'm using some of the lower level stuff like the, what's this embedded HAL? This generic embedded HAL layer for things like what are input and output pins and what's a timer. Using smart LEDs for the NeoPixel that you see blinking. And I'm using there's an embedded USB device stack and USB serial and USB human interface device classes. So I didn't write any of that. I guess you could say that's what my keyboard firmware is based on. A lot of that's the work of the RP RS. Is that the group? RPRS? There's a, yeah, let me find that. GitHub RPRS. Yeah. So this is probably the closest thing to answer your question about what the base repo is this guy. So they provide, I think, the Adafruit board support package is probably in there somewhere, but at least all of this stuff, everything that these guys are written, I'm using a lot of their stuff. Working memory is completely overloaded by the time we get to version control. You always admire people who can write commit messages without viewing the diff. It's easier when you commit more often. So if you wait a long time, like sometimes I'll wait an entire stream before I commit, and then I have to look at the diffs because I'm like, what the heck did I do this stream? All right, so back to my plan. we did part 1, right? So part 2 is to combine the bitmaps from both keyboard sides. Let's do that. And that should be a change to our inner board communication, right? So let's look at the messages we have defined. Yeah, so this key right here, I need to change that. Instead of an array, it's just going to be a U32. It's going to be our key bitmap. So that means some of our tests change, right? Yeah, so these ones about decode key, instead of being a message being a U8. No, that's fine. It's this thing that's different, right? Actually, this would be. So let's make a bit pattern here, like 10101 or 101110. I have no idea what the sequence will be. Let's let the test tell me what it is. Oh, it won't compile. Okay, I need to at least fix the compiles. It's down here. Because the actual numbers that go in here depend on how the base crate we use, which is bin code, how bin code will encode that binary number, right? So I'm just gonna let bin code tell me what it is. Okay, so it's actually only 2 characters long. Okay. Interesting. Well, that's better, right? So it requires fewer bytes to actually transmit the key bitmap, and it's 46. Okay. So 46 on both ends. So if we decode 0146, we will get that binary. Let's run all of our tests and make sure that nothing else needs to change. Okay, so all our tests pass. Great. So then let's just follow the compiler errors. So rusty keyboard. Actually, it doesn't tell us where the error is. Cargo. Clippy? Keyboard.rs. How come it's not showing it here? Do I need to reload this guy? Reset. Restart server. There we go. Let's try that. It's running. Okay, there we go. Must have pulled the rug right out from under it. Okay, so yeah, it's not going to be a vector, right? This key message is going, so it's not a key message anymore. It's a key. It's really keys, right? So this doesn't need to be a vector anymore. It's just a U32, and just pure keys equals keys. Okay, and then where do we use pure keys? Up here. So that's make it a 0. Assume that there are no keys pressed on the peer. And is that it? As the code is not littered with let mute, how many copies of the key code exist before the handling is wholly completed? I don't know. I tried to minimize the number of copies. What protocol driver would you recommend for a beginner to implement from scratch? Depends on what you want to do. What is peer? The other guy. So if we're talking about from the perspective of this guy, the peer is him. If we're talking about him, his peer is him. So my convention is whichever side is plugged into the computer is the left-hand side. So if I were to swap these sides around, then I would also swap the connector around. I didn't put the extra work into making it arbitrary which side you plug in. If I did that, then I'd have to have some other way of the boards knowing which one's left and which one's right, right? like some non-volatile storage, like something that says, oh, I'm the left-hand side or I'm the right-hand side. So yeah, whoever is plugged into the host is the left-hand side, and he's like the main, what I call the primary board. And then the secondary board is the one that is not plugged into the host, but it's getting power from its peer. And in general, this is going to be the subordinate board. He's going to be sending his key bitmap over to this guy, and he'll be combining the peer's keys with his own keys, and then forming a report to send to the computer. And the other function is that when the host sends a new firmware image to the primary's job is to forward it over this cable to the secondary, and then wait until the secondary is done programming the firmware, and then finish programming yourself, and then they both reboot together, which is I kind of like how I did that. If you want to code everything yourself, RimuPath is good. I didn't do everything myself for this project, though. Again, I based a lot of it off of RPRS. Oh, another project that you might want to look into is the Pinchy. Oh, I don't have a command for that. In my notebook, though, I have a link. This one. If you take a look at this project, they have their firmware also, and if you just look at their cargo toml, you can see that they used Kiberon, and I believe that is I looked at this, it's a pretty good library for if you want to like make your own keyboard firmware in Rust. So if you just look at, just look that up, Kiberon. It is, this is wrong. We'll just click this and we'll see the real thing. It's a Rust crate for pure Rust keyboard firmware. So they have a lot of example keyboards that have been made, firmware made using their stuff, but they handle a lot of stuff I'm coding myself right now, right? So they have layer support, they have hold tap, and if we look back at their repo, oh, I shouldn't have done that. I closed the wrong thing. Kiberon, if we look at their repo and then look at their source, so they handle chording, they handle the debounce stuff I did today, right? Maybe they did their debounce better than me, I don't know. But the layout, the key matrix scanning, they also have the HID stuff. So this would be a good crate if you wanted to do it not from scratch. But I like doing stuff from scratch that's within my ability. Yeah, take a look at this Pinchy open source keyboard if you want to do something like what I'm doing, but not have to write everything from scratch. Let me close this stuff. All right. Anyway, I'm moving on to the next step, I think, right? We are going to transmit the peer keys over. I don't think I'm actually using this right now, right? Okay, we're receiving them, but we're never transmitting them. Right, I had that section of code commented out, where if we are the secondary board, this one, let's bring that back out. If we received a greeting message, we are the secondary board. And oops, and should stop here and just send the primary board any changes in our key bitmap. Otherwise, we should be combining our key bitmap with that of secondary board and continuing the process of converting key bitmap changes to HID reports. All right, so that's this if else, right? So if we receive the greeting, like I said, we're the secondary board, so we just forward not our key codes here, but our key state debounced. So actually this should go into here, right? So let's move this into here. So we're gonna send our key state debounced there. Okay, else we're going to combine our reports together. So that's this part, right? That means I should have a combined state, right? I don't have that yet. Oh, wait, why don't I just, why don't I just combine it at this point? Actually, problem is, actually, I do want to do that. Okay, so let's I need to, how do I say this? This isn't even correct, right? I need to split some of this up. So let's first just say update raw key state if it changed. And this is only to log this message. If it weren't for that, we would just store it directly into here. And yeah, here at this point, I should say, if we, actually I can just copy this, right? Right, Reimer, you can. If we did not receive a greeting message, we are the primary board. And should combine our key bitmap with that of the secondary board. Period. If not self.received greeting, then yeah, then key state debounce should be ORed with self.peer keys shifted left by the number of keys we have. So that would be num rows times num columns. Then we update our debounce key state. And if we received a greeting message, we are the secondary board, just stop here and just send the primary board any changes. Otherwise, we already did this. We should continue the process. Okay. That's how I think I want to do it. Just want to dip your toes in the water. Tried writing a bootloader from scratch. Didn't go well for your health. What I'd recommend, actually, if you want to dip your toes into Rust firmware, if you're on this Raspberry Pi 2040, is to go to that link that I had. I can search for it again. RPRS. They have a great getting started crate to start with. It's called this RP2040 project template. So you clone this repo and just run it, and it will, I think, just blinks the LED. And they have like detailed instructions on how to get it up and running. Right at the end, you just get a blinking LED, and it's a great starting point, and that's what I started with. So definitely recommend this as getting started. Does the latency vary between primary and secondary board? Well, there will be some latency going over this, but I don't think it will be significant, but we'll see. I don't think so. I don't think it'll be. Yeah, that project template really worked for me. But again, it's only going to work for you for this RP2040. It is a pretty cool microcontroller. Raspberry Pi comes out with great stuff, right? It's pretty cheap. You can either use this Keeb 2040, or the Raspberry Pi also makes a Raspberry Pi Pico, which has the same microcontroller. It's just a little bit bigger of a board. That's what the Pinchy board is using. So you get yourself whatever board has an RP2040, and then you can start with that starter project and get up and running pretty quick. I think the only thing you need to do with that project starter is to say which board you have, and like I just picked KB2040. You could pick the Pico instead and it should just work. I think this is TBD, right? Actually, all of this stuff should be inside of there. Right? I need to figure out why this is required in order to get the USB pole to return true. I'm guessing it's because we need to actually write something initially to the log. But I'm like, no, that can't be it. I'll figure this. I'll just right now put this in here to fix me. Unless we send a keyboard report. Our polling of the USB device. Whoops. Doesn't succeed and allow us to flush our log buffer. Until I figure this out. Let's just constantly send keyboard reports. To the host, even if our report hasn't changed. Actually, this key codes, really we should be moving down to where we're going to construct a report. Build a... This key codes only like has the key codes, but really it should be a whole report. It should be this whole keyword report, shouldn't it? Complete with modifiers and LEDs and all that junk. So I think what I should do... Oh, wait a minute. Except for I can't construct the way to compare these, right? That's fine. We don't need to do that yet. Build the current HID report for the host. This is to do. Haven't done it yet. Now I gotta look at my diffs to make sure. Did I actually check this stuff in? No, I didn't. Okay, so before I get much further, I do want to check this in. Let me build and program it to make sure I didn't break anything. You have one of those looking to buy a new Pico W? Can't find one? Have you tried Adafruit? Let's see if they have one. Where it's this one, right? See if they have a Pico W. Oh, it is out of stock. Well, that's a bummer. Do they have the KB 2040? Oh, those are in stock. $9. Mm-hmm. I mean, $6 is pretty cool. So for $3 more, you can get the board I have. I guess because this one has the Wi-Fi built into it, right? That's pretty popular. So is the Pico without? Oh yeah. So you can get the one without the Wi-Fi for $4. That's in stock. Ooh, with headers for an extra buck. Yeah, I guess the Pico W is just really popular. Takes a while for stuff to cross the pond. Another thing you can try is DigiKey. Let's see if they have stuff. I guess does it matter if what country you're in for DigiKey? Ooh, I guess maybe you can't buy it through DigiKey. Yeah, maybe not, huh? Oh, here we go. 0 in stock. No! Okay, we tried. Yeah, because it's a very, very popular board. I can't even get it. Programming, stand by. Most of the time is actually spent sending over the serial port here the entire firmware image from board to board. Alright, testing. Oh, we're back to this bug. Why is that? I probably got this backwards, didn't I? Oh, wait a minute. We're always doing that. But only if the key state debounced. Is that the problem? We're not sending it fast enough? That's probably what it is. Okay, well then, let's just move this out then. Yeah, we'll just put this here. Close and build and program. Silicon is the new gold. But that didn't fix it either. Well then I'm not really understanding why the USB is stuck. Well, that's really strange. Oh, because I didn't move it all the way out. Duh. That needs to go all the way out. Okay, I feel dumb. I need to unconditionally send it every time we scan to keep it moving. For I don't know why yet, but we'll find out later. See, it's like not updating even though we're programming. It's like the USB pipe is just getting stuck. Maybe just we're supposed to be able to write it even though poll returns false. So if I hold down a key there, now we have... Right. Okay, but I'm not seeing it update on the left unless it has a it has an update, so I need to fix that. This should have done that. Okay, why is it not doing that? So if I change the right-hand side and then do the left-hand side and then release the right-hand side, I don't get a left-hand side update here. Why not? I have to actually release that and then I see... Wait, why is it still stuck? Wait a minute, it's stuck on this side. Oh, hold on, I know why, because I or equaled... Okay, I have multiple bugs here. We don't want to do that. Actually, that should be fine. Wait. Just peer keys, right? Just whatever they send us. It's generated from over here. State key debounced. Then I don't understand. Hold on. I thought I knew what the bug was, but now I don't understand it. Let's reset this board. Okay. Okay, so when I'm not pressing anything, debounces all zeros, right? I press one on the right-hand side and release it, and then press... Okay, so I saw it correctly go to that state, but I didn't see it go back to 0. Why not? It should have transmitted to the left-hand side an update. These seem to me out of order, but maybe that's okay. It should have transmitted its report to the left-hand side again, and the left-hand side should have seen it go to 0. Why did it not? That should have happened. Why didn't it? Reset it again. Okay, and then hit a key over here. So that's correct, but then when I release it... Okay, it's getting stuck at a 1 and not going back to a 0 ever. Why is that? See, like they're all stuck on now. All the right-hand side keys are stuck on. Why? There shouldn't be anything different between is down being true or false. And the right-hand side report is correct. That's all correct. Oh, wait a minute, wait a minute, wait a minute. Oh, I know what I did wrong. This is initialized to the previous state. That's the problem. Okay, that's fine, but I need to mask away the right-hand side bits, or I need to compute this differently. Let me think about this. So, another variable maybe for the combined versus the left-hand side only? No, I should just mask them away, shouldn't I? I could do it at this point. Yeah, I can just say key, well, what am I doing? Yep, there we go. Can't type. What time is it? It's almost midnight. Is this my indication that I can't type? The this should work, right? So number of rows times number of columns minus 1 will give me all 1 bits. Why does it not want me to do that? Mismatched. Found U8. Oh, that should be 1 shifted left that many. And then minus 1. It's probably going to tell me it's operator precedence is going to trip me up, so there I'm explicit. And then I don't need these. So that masks out the upper bits and then combines them with what the pure keys has. Yeah, let's do that. Then what's the warning down here? Oh. Yeah, yeah, that's fine. Okay. Yeah, so the problem was I was ORing them in and then storing them and then reusing them in the next report rather than forgetting them and always recombining with the previous. Actually, there's another way I could do this, right? No, there isn't. I thought there was a way, but I just thought of it as it's wrong. Okay. Cool. So the right-hand side sees a 0000001, but then it gets when it gets sent over to the left, it's shifted left 6. So that's the highest key there. Cool. If I press all the keys, they're all hit. That's kind of fun. Cool. So I have a combined bitmap on the left now. Look at that. Okay, so now we're good. So I can check this one in. Quit. So this is send right hand key bitmap to the left and combine. Okay, we did step 2. So we've done step 1 and step 2. So step 3, compare the previous bitmap to detect. Compare with previous bitmap to detect which keys are newly pressed or released. Okay, so that we can use to do a form our key map, right? Yeah, our key report. So yeah, let's do that. And that's down here. So this is a detect newly pressed or released keys. How do I want to do this? Probably just go key by key and see if there's a difference between the current debounced keys and the previous. Because, oh, I changed them up here, so I kind of want to change them later. Like down here. Yeah. Actually, I know that up here, right? Well, but except for it gets combined there. Yeah, so we just want to do it here. For key index in 0 to... I really should have a constant for this, so why don't I just make it up here? Const num keys. U8 equals num rows times num columns. Okay, let's search for this, because I know I've done this computation in more than one spot. Yeah. So these should both be num keys. Okay. And then down here, it's from 0 to num keys. Let key mask equal 1 shift left key index. Now that I think about it, I had like key or mask. That could just be key mask, since we didn't need a key and mask. All right, so let key mask is 1 shift left key index. So if self dot key state, oh, it's just key state, right? Key state debounced. Exclusive or... Why don't I pre-compute this? And then I can skip the whole thing if there are... well, there's going to be at least one change, right? Can't I just do that up here then? Let keys changed equal that or this. Doesn't that make more sense? And then this can just be if keys changed is not equal to 0. Actually, can I just say if keys changed, or is it going to complain? Yeah, I have to say like not equal to 0. Okay, so then if I can get rid of this, let if keys changed and not key mask oh, it's almost midnight. It's not equal to 0. That means this specific key changed state, right? So it matters if it's pressed or released, right? Let is down equal to key state debounced and key mask. Did I get this backwards again? I got that backwards again. Does the keyboard turn back into a pumpkin at midnight? I turn into a pumpkin at midnight, and pumpkins don't code very well. If you use it more than once, why don't store the result in a variable? Yeah, exactly. That's what I did up here. I could also just shift left once. That's probably a smarter thing to do, right? Let mutable key mask equal 1, and then shift it left here. Key mask left shift equal 1. That's probably smarter, right? Then I don't even need the key index, do I? Well, I agreed with you. I'm not sure how to say your name. I'm gonna say Affy. Affy, I think I agreed with you. You're right. I stored it in a variable. If you meant the keys changed, right? Or if you meant key mask, then it's different every loop, but we don't have to do the whole shift by the... We don't need the key index, right? We can just shift left once, and that's maybe more efficient. I don't know. You know, the other thing I can do, I don't even need the key mask. I could just take the key state debounced and well, hold on. We need it down here. I was gonna say we could just shift right and with 1, but I think this is probably better, right? Yeah, okay. So if it's newly pressed, let's just add it to the report. So that's one of these right down here. Key codes, right? Well, hold on. Let's make a whole keyboard report. Let mutable keyboard report, right? Okay, and then we'll say if is down, keyboard report dot keycodes dot... Oh, hold on. That's why I had this special keycodes class, because it handled like adding and removing to it. I remember now why I did this. So let's just do keycodes. So then it's just keycodes, and then I have methods on that, right? Just add. Okay, so I need to actually compute the key code here. That had to do with oh, right, we don't need this anymore. I wanted these numbers, but I was just gonna hack it right now. And let's just say const. I can put that up here, right? This isn't gonna last. This is not gonna last that long. U8 12 equal 3 4 5 6 7 8. What was the next one? Oh, it was starting with 4. 4 5 6 7 8 9, and then 30. Right? Yes. 31, 32, 33, 34. I'm just totally hacking this in here. So I can just index from the key number. Well, so then I do need the key index. Key codes. Key index. There. And this should be, again, this not equal to 0. Mint keys changed and you pronounce your name nearly perfect? Affy? Okay. I'm glad. What did I do wrong here? Ew. Key index as usize. It's funny how you can't index an array by U8. You have to convert it to usize for it to be indexed. Okay, and then I think what I'll do then is until I fix this, we're just going to keep sending it. So that means what I'll do is I'll start with the previous. So it's self previous. Wait a minute, didn't I store it somewhere? Oh, I never did. Okay, so I will have to do that. Key codes. Yeah, I regret having to add this, but it's only temporary. It is a key codes. Which means when I initialize it, it is key codes default. Previous, and then get rid of this. And then I hope I have a remove. I don't. Okay, we'll need to add that. There, I can just delete that. Why not? Oh, shoot, I need to move this all the way at the top. All the way out of this. Wait. That should be fine. Why doesn't it let me do that? Oh, right, because it's a different type. Into. Okay. Yeah, I need to add a remove here. Dang it. This is a problem. Because that means I'll have to find it and then shift everything over. You know, it's not that bad. It's similar to add, right? If any... Really want to go through them all, so let... Actually, I want to do a filter, don't I? I want to filter them and then add a 0 at the end to make it the correct number. Let's just do this. Imperatively, right? So let mute... well, it's just 4. I in 0 to self.key codes dot length. Let mute this should be -1, and then found equals false. If found, self.key codes dot index I equals self.key codes I plus 1. Else, actually, it should be up here. If not found, if self key codes I equals key code, Well, this should just be found equals that. It should just be that, and then down here, if found, self.key codes. It should be -2, right? Because it should be that -1 equals 0. It's probably a much smarter way to do this, but I'm not going to worry about it. And then here I could subtract 1. There we go. So we haven't found it yet. We go from 0, let's say the length is 6, right? So 0 to 4. 0, 1, 2, 3, 4, yeah. Actually, this should go to the end. If we haven't found it, see if it is there. But this should be if, trying to avoid doing this twice, but I don't think I can avoid it. If I, how about this? If I plus 1 is less than this length. It can be collapsed? Oh, sure. This is shifting them over if it finds it. And this is to handle the very last one. Just fill in a 0 at the end. And also subtract 1. Okay, I think this will work. So back to here. So we're kind of doing that, but we're not done. Okay, let's just try this. I should be printing out what this is, right? Yeah, I had that before, right? Hold on. Go to history and go to where I changed all this, right? I had this printing what I wanted it to print. Here. This thing. I want that out of the history. Okay, so then that... Wait, did I not need to add this previous key codes then? Why did I think I needed that? Oh, right. Okay, I did need that. That means I need to update it at the end. Oh, all right. Yeah. Okay, that goes here. Well, hold on. Yeah, okay, so so we'll do it here. Self.previous key codes. This is a hack. All right, let's do that. These structs in Rust, yep, they're all in Rust. This is 100% in Rust. Reprogramming in progress. Oh, are there structs in Rust? Yeah, that whole self thing is a struct. How come I can't click on it? Actually, I can just go to this. So this whole thing is a struct. It's a struct with a large number of things in it. Here's a smaller struct, this key codes thing. So it just has an array and a number in it. So it's kind of weird if you're used to C++, you would have like your methods declared inside the class or struct. In Rust, you declare the struct separate from its methods. So it's just the data and then just the methods. All right, let's see if it worked. So there's a key report of 4. Now it's 0, 5, 4, 0. And what about the right-hand side keys? Okay, that didn't actually work. Okay, my right-hand side keys aren't making it through. Oh, shoot. I forgot to multiply by 2. Yeah, I know what I did wrong. We said from 0 to num keys, right? Should be from 0 to num keys times 2. Because they're 2 halves of the keyboard. Oh, we have this delay again. Time to hydrate. Sometimes my Windows computer has trouble connecting to the COM port. And there's like this delay of 30 seconds or so, and I don't know why it is. There it goes. There's no error or anything, it's just sort of timing out at some point. Ba-da. Okay. There we go. So what happens if I exceed the number of keys? So now they're all held down. I release one key. That was interesting. It's hard for me to hold down exactly 5 keys. To use all my fingers. Okay, so there's a bug in there. There's a bug. When I release key code 4, the keys didn't go all back to 0, like they should have. So there's a bug in there. Maybe the remove doesn't go all the way to the end. Hold on, let's see. I mean, that should have worked. What happens if... So next just start at 0, right? Yeah, it's because it's deriving default, right? So next should be 0. So it should go up to 6 when max key codes is 6, right? Yeah. So it should put the last one in index 5 and then go to 6. So when we remove it, we're going to... Well, that len is always max key codes. Why don't I just use that? Actually, I should just be consistent. That length is max key codes, right? This should be a constant function, yeah. So I don't... Yeah, it's not... That reduces to the same thing. Anyway, this will scan from 0 to 5, right? So it should hit the 5th element and it should detect that it's there. This will be false, so it won't do that, but it should fall out and then that's true, so it should... set index 5 to 0. So I don't know why it's not working. And I already quit it. Okay, so let's run it again. Let's try this again, but maybe... another delay. Is it fun to code in Rust? It's fun for me. What's the most annoying? I think the most annoying is that when I am used to programming in a certain way from C++, and I make a whole design, and then Rust tells me, that's not safe. Usually it's the borrow checker that tells me that I can't borrow something twice. I already have something borrowed from one line of code, and so I can't borrow it again from a further down line of code or something like that. And then it gets kind of annoying because I have to rethink how I designed it. And it'll take me a while to realize, like, why is it, how did it happen that I accidentally borrowed the same thing twice, immutably and mutably, right? Or mutably more than once. And then it takes me a while to figure out how it happened, because it's not something I'm used to thinking about. And then once I realize what it is, it's annoying because I have to go think of a different solution. But in the end, I think it's teaching me better habits. So the way you code in Rust, you can go back and code it the same way in C++ and it'll work. It's just Rust is a lot more strict. Hold on a second. I gotta mute and hide the camera. Sorry, my kids take priority. When they want to say goodnight, then I have to, no matter what I'm doing on stream, I have to pause. Okay, let's test this again. I wanted to hold on 5 keys from the left and press 1 on the right, and then release it. See, it correctly identified that that key on the right-hand side left, but then the key codes didn't change. Unless I release a key there, and see, the one from the right is still in the list. Yeah, another stuck. Interesting. So there's something in this release code that I'm not seeing. There's some bug here. I mean, this is really not that great code to begin with. What did I do wrong? Think that is the right attitude with your kids? Yeah, that they take priority? Yeah. So chat, your second priority. My kids are first priority. This is correct, right? We found it. We should go from, this is going to be 5, so it should find it at index 5. If not found, found equals. Does that mean you cannot access the same atomic variable from 2 cores simultaneously with Rust? It depends on access. You can immutably access it from 2 cores simultaneously. That's fine. You can't mutably access it simultaneously. I think the atomics are different in that they... how does the atomics declared? Yeah, mutably means right. So hold on, let's look at atomic. So you can just pick any of these, right? So like a store, for example. Yeah, that's right. So you see how store doesn't require a mutable reference? So that allows you to share it between 2 cores and they can both call store. The atomic makes sure that it's safe. Normally when you're going to write to something, you need mutable access, but with an atomic you don't. So if it truly is an atomic variable, as in it's one of these atomic types, you can do it simultaneously from 2 cores because you can always send and share a immutable reference. Yeah. I don't think it says it here. Maybe it says it at the top of the atomic module. Blah, blah, blah. Atomic variables are safe to share between threads. They implement sync. So, but they don't provide a mechanism for sharing. And so the most common way to share it is to put it in an atomically referenced counter. That's just because the ownership needs to be such that it's either like, you have to guarantee that the variable will still exist for both cores, right? So a common way is to give each core or thread a different reference. Or you can just make it static lifetime, or make it the lifetime such that it'll always live as long as the code accessing it will. But this is a pretty common way of doing it, right? That's the only thing. That's the only caveat. You have to make sure that it exists for the whole lifetime. Okay, I'm kind of stumped what I did wrong here. It's like this isn't being executed once I even closed it. Once I fill up the array, it's not removing it again. It'll definitely try to do that, right? Because it doesn't care what's in key codes. So it's gotta be that remove thing. It's not something dumb like this, is it? Is that something that's that different? I guess I can try that. You know, when in doubt, add parentheses. I mean, Rust isn't complaining, so maybe I do need to do something like that. I don't think that that's it, but who knows? Adam! How are you doing, Adam? I'm working on my keyboard stuff. How was your stream? I'm usually the one rating you. Why are you rating me? So, hello, I'm Raimu. I am working on making my own keyboard. This is not it. This is like a little baby step from going from nothing to a real keyboard. My stream is quite different from Adam's, so I'm not doing so much art because I'm not an art guy, so sorry if you're here for the art. I'm more of like a maker and a builder. I'm trying to make something like this. This is a Korn keyboard, so it's like a 36 key keyboard split so that you get 18 keys on each side. So there's 3 rows of 5 keys and then 3 thumb keys. So it's less keys than a normal keyboard, right? You get all the functionality by layering things on top of each other. So you hold down certain thumb keys and you get numbers. Other thumb key combinations give you the arrow keys, that kind of thing. But I'm trying to make one almost from scratch myself. And so I'm doing a combination of circuit board design, Blender, modeling, 3D printing, and coding. So I'm doing the firmware, the code all in Rust, and they sit on these little microcontrollers. Going to a game dev tonight, so early finish. All right, right on. So what I am using is the microcontroller from Raspberry Pi called the RP2040. It sits on this lovely little pink board, and I have one on each side of the split. There's a USB-C connection. Really, it's just a serial port and power. That's how this guy can have power, even though he's not connected to anything else. And I'm writing all the, like I said, writing all the code in Rust. And so I'm handling everything from, I made the circuit board myself, and I'm making the larger one too, the full size, to all the way up to talking to the computer over USB. See ya, Adam. So I guess the closest thing that I've done to what maybe you might see on Adam's stream is I do a little bit of Blender for modeling. And let me show you what I worked on this weekend. So it's this guy. And I modeled this. It's got standoffs and through holes. So it's this guy. It's the full-size version of what you see around these. If I bring this closer to the camera, there's a little 3D printed plate that kind of holds all his keys in rows and columns. And this is the one for the full-size one, so it gives you an idea what the final keyboard is going to look like. And so this is on top. The switches go in the middle. The circuit board goes under that, and then under that is this chassis plate that's also modeled in Blender and 3D printed with little nickel inserts for screws. So the screws go right through. And once I get the PCB and populate it, it's going to look like my corn keyboard, only it's going to be all mine. It's the Rusty keyboard. Thank you, Pen Paul. So, although I have the hardware in front of me, I'm not doing hardware design stuff today. I'm trying to fix some software issues. So, right now, like, as I press these keys, you can see that I get the raw key matrix, like a 1 bit for every key that's held down, and then we debounce it. And that means if there are like a spurious state transitions, we kind of eliminate those so that like glitches, we get rid of the glitches when we pass it through our debouncer. And the next step is to form a key code report that we send to the computer, and we have exactly 6 slots, so we only can register 6 keys down at once over USB. And that's at the point that I'm rewriting that code today, and I'm making sure it works. And I have one bug where if I hold down 5 keys on one side and I press a key on the right and then release it, we never got a key report with a 0. We should see one of those again, and we don't. In fact, if I release all the keys, that 30 key is still stuck, and it stays stuck until I press it and release it again, and then finally it goes away. I'm trying to figure out what I did wrong. So there's a bug somewhere in my Rust code, and I think it's in this function here. So this function gets called whenever we determine that a key is no longer being held down. So back up here, if we go from that to what was it? We want to see something like that, but where 30 is removed. So we want to see 6, 4, 7, 9, 5, 0. And for some reason it doesn't happen. It should have happened right here, right after this guy. So it didn't happen. I don't know why. So it's when we have this array and we say remove 30 from it. So it's in the last index 5, right? 0, 1, 2, 3, 4, 5. So 30 is in index 5, and we say remove 30. Why is it not working? So this is for I in 0 to 6 minus 1 is 5. I know what it is. This is not including the endpoint. So there we go. That was the bug. See, it took Adam rating me to figure it out. No. What I do is called rubber ducking. So the idea is that while you're working on something, sometimes it helps to explain what you're doing to a rubber duck. And you can, hold on, let me look it up. Rubber ducking. This is a real thing. Or rubber duck debugging. Okay, that's what it is. So this is what I do on my stream. I am, chat, no offense, but you're all rubber ducks to me. Just kidding. The idea is you explain what you're doing as if you were talking to some inanimate object or some animate object even. So like telling a friend next to you what you're doing, that you can better understand it yourself. You can confirm that you understand it, and then you can actually help yourself solve problems just by re-explaining what you're doing, and then you'll catch yourself and, oh, I just noticed something, right? So that's what I just did now. I think there was a bug there, and I think I just fixed it. So let me confirm that. Quit this program and I'll build my code again. I know, Quack. Hey there, I am Eno. Okay, so to explain kind of what I'm doing, build is compiling the firmware. Program is running this little guy who connects to the keyboard. He sends the new firmware image over the USB. This guy stores it and then forwards it to the other guy, and then they both at the same time go and they reprogram themselves. And side note, this should have done it by now, but there's a little bit of a lag issue I haven't figured out. On my Windows machine, it takes about 30 seconds sometimes to actually connect to the keyboard. I don't know why. It doesn't happen every time. Gives me an excuse to hydrate while I'm waiting. Okay, there it goes. So it transmitted the program all the way to this guy, and then he's forwarding it to him, and we're doing like reprogramming it one sector at a time. And then Now it's at the end, now it's committing it, and then it reboots. So now we're running the new program. So here, my goal is hold down 5 keys on the left. Oh, it's still connecting. Okay, we gotta wait again. Gotta wait till it says connected. Hydrate again? I think so. All right. I want this to be working this time so I can move on to the next. Okay, there we go. So hold down 5 keys. So you can see the key report is everything that I'm holding down and then a 0 at the end. And then I hold down 1 key there, so the 30 goes in there, and then I release it. Cool, it works. And I release all the keys, it should go all the way back to 0. So this should actually work as a keyboard. Like if I just start typing A, B, C, D, E, F, and then 1, 2, 3, 4, 5, 6. There you go. See, it works. I can only type A, B, C, D, E, F, 1, 2, 3, 4, 5, 6, but hey, that's all the keys we need, right? All right, so let me check this code in. So we do it. I'm hopefully Adam does this too. We commit to Git often and always. So let's check this in. So what I'm going to say here is form HID human interface device reports from debounced keys. Okay, and then I'm going to go back to my notebook to see what the next thing to do was. So we just did 1 through 3 in the stream. 4 was next, but I'm kind of running out of time. So maybe I do this next stream. We also did 5. Yeah, so 4 is the big thing. This mod tap is where you can have a key that is either if you tap it, it means one thing, like the number 1, and if you hold it, it means something different, like shift. And so there's a whole bunch of like weird logic we have to do to either tell the difference between holding a key down and just tapping it briefly. Are you using bit correction? You mean debouncing? Yeah, so this is the idea of how we correct bits. So if 0 means we're not holding down the key and 1 means we are, and going from left to right is the axis of time. So we're not holding the key down, we're not holding down, and suddenly we start pressing it, but it's right on that edge, so we're getting like a bunch of noise, and then finally it goes steady 1, we're holding it down. The debouncing algorithm waits until there are a whole bunch of 1s in a row and says, okay, we've decided you really are holding down the key. And then it'll throw away spurious 0s and say, oh, no, we're still holding it down. And only until it sees a bunch of 0s in a row, it says, okay, you finally released the key. So you can call it debouncing or bit correction. It means the same thing. We're correcting these transients, these brief toggling of state. And we're saying, well, we're sampling the key so fast that there's no way you can press and release the key that fast. It must be a glitch. So we're removing these 0s, this 0 and that 0, and basically giving us steady 0s, 1s, and then 0s. You can tell that there's a little bit of lag. We might have actually hit the key there, but we don't know it until there. But this happens so fast, it's less than a millisecond, it's imperceptible. So like if I type now, like I can't tell that there's any lag. It looks instantaneous to me, right? Because my brain will be unable to perceive a delay of less than a millisecond. We can show that the debouncing is working if I run the log program. We have to wait for it to connect. In the meanwhile, let me make sure that I didn't miss something. Yeah. If it wasn't for this lag in connecting, I wouldn't have my stride broken. Anyway, maybe while I'm waiting for that to continue, I can look for opportunities to clean up this code. Really, I should be refactoring this into separate functions, right? Oh, I can get rid of this. We don't need that anymore. So this is the function that gets called like 50,000 times a second to scan the key matrix. Oh, I can describe what we're doing here. It all feeds back into the schematic for the keyboard. So if I run my schematic program, show you the schematic. So this is what it electrically looks like. On the real keyboard, mind you, the one with 18 keys per side, there are 18 switches, 6 columns, plus the thumbs, so that's a 6 columns. 6 columns by 3 rows, and we call it a key matrix because it really is arranged like a matrix. There are, for every column, there are 3 keys connected on one side to each other, and on every row is where we connect the other sides of the keys. So a key is really just a switch. It's either a broken, what am I trying to say? It's either a place where the circuit is connected or not. And pressing down a switch connects the circuit, right? So the idea is we go through one by one with these rows, we drive a signal through, and then we see if the signal ends up in any of these columns. So the way this, especially with the diodes where they are, you'll only see a signal from a row end up on a column if the corresponding switch in between them is pressed. So if I drive a signal on row 0 and we see it come back on row 0, column 0 and 2, that means switches 1 and 7 are closed. So that happens, that scanning happens like 50,000 times a second. We drive, I switched in the code between rows and columns. In the prototype, it's rotated, but it doesn't really matter. So we drive in one dimension like column. We drive it low, right? Then for every row, we see is the row low. So if I go to scan key, it's just saying is the row low? If so, then the key is held down, right? And then at the end, we're going to drive that column high and then go on to the next column. And then which key it is depends on this equation. It's the column number plus the row number times the number of columns, right? So 2 columns, 3 rows, the index is going to be from 0 to 5 because we have 6 keys. You made a base 32 5-bit alphabet the other day. Just removed 0, 1, X, Z from A to Z and 0 to 9. That way you can store 6 characters in a 32-bit integer. Nice. That's not too different from like the official way that base 32 is done, right? For things like encoding numbers and binary code in ASCII. So anyway, when you look at this code, I hope it makes sense when I show you the schematic that it really is a matrix with rows and columns, just like it's physically arranged. And to tell if a key is pressed, we have to drive a signal out one dimension and then see if it comes back on the other. A lot of the code here in here is to like catch, like this debouncing algorithm is to catch glitches on the line because it's not a perfect system. Right on the edge of when the key is pressed and not pressed, there can be like noise because of arcing of the current, and there could also be current flow, right? Voltage doesn't instantaneously change from 0 to 5 volts or whatever. There's a very fast but greater than 0 amount of time for that to happen. So that's called a bounce or a glitch or a bit error, however you want to call it. So we have to have an algorithm in place to catch to catch that. The core of it is here where we are looking for key transitions, and if there is one happening, then we wait until a certain amount of time has elapsed without it falling back, and then we say, yes, indeed, it's transitioned, so flip the bit in our key state. I have to do a bunch of other stuff like combine the keys from one side with the other to get a full record, and then like here's where we send the keys from one side to the other, and here's where we combine them on the other side. It gets a little complicated because the same code is running on 2 processors simultaneously, and they're talking to each other through that serial cable. So the same code is being run in parallel on 2 different devices at the same time. So that makes it a little bit complicated to explain. Made a 4-letter language, so you could use my keyboard then. This is exactly the correct number of keys to type in that language. But yeah, if you guys have any questions about what I'm doing, I can explain. Although we are reaching the end of the stream because I got to go to sleep soon. Oh, I was going to go back and test this some more. Right. So a bounce would be if at any point we see... Oh, there's a bounce right there. We got it right away. So here's a state where we were holding down a key. So it was key code 4 or key index 0. So there's the 1 bit is the last bit set there. And then we saw it go away, and then we saw it come back, and then we saw it go away finally, all within the space of less than a millisecond. So the debouncing algorithm prevents it from looking like we hit the key twice. If I didn't debounce it, we would see it go from on to off to on again, and then finally off. We'd see 2 key presses where there really was only 1. So you can see although raw went from 1 to 0 to 1 to 0, the debounced only changed from 1 to 0. So that's what the debouncing does. Hope that makes sense. Need 32. Actually, I need 36 keys. So I am... Oh, wait a minute. Good point. I just thought of something, Tinspin. I'm only using a U32, but I have 36 keys. Don't I need it to have a U64 at least for this keys changed? This has got to be U64, right? I just realized that. And so does this. See, this is why chat's awesome, because you guys like help me remember, or you help me think of bugs before I run into them in the wild. Yeah, so all this has to be U64. Actually, we can get away with the peer keys being U32 because per side there's never going to be more than 31 keys. It's going to be, for me, exactly 18 keys. So that can stay U32. But where we combine them here, that means I have to do like U64 from that. Right. Okay, so key state debounced. That can be U32 from, or as U32, if we're going down. Okay, and that should be it, right? So Rust will figure out from all of the type inference that everything is U64 now. Yeah. So let's build that and make sure I didn't break anything. Oh, while I'm at it, let me increase the number of bits we print out in our diagnostic log here to 12. Is it just that one place? No, there's also the raw right here. Well, raw is always 6, right? Debounced is where it goes to 12. Yeah, so build and then we'll program again. And we're in the dreaded connecting state. That's fine because I need to check this in. So we're fixing a bug that Tinspin helped me figure out. That we need 64 bits for our key bitmap. Right. We need at least... or we will need at least 36 bits for our final key bitmap. So use a U64 instead of a U32. That sound means that my programmer just finished, by the way. Okay, so fix bug in type used for key bitmap. Close that. All right. Oh, it's still connecting now, but we did program. Oh, now it's done. Okay, let's test it. So So we can see the debounce shows us the full report. So if I hold down 3 keys on the right, you can see those bits are held down. So it's all working. The older VODs available on YouTube? Yep, they are. Here's a link for you. I have them in a playlist. So if you want to, you can go see all the previous 20, although the number 20 I haven't transferred over. I also want to make a condensed recap video eventually. When I'm done building my keyboard, I tend to go through all of my VODs and pick out the choice moments. Say like, well, in stream 6, we did the circuit board design, and oh, here's an interesting, you know, stuff like that. And I'll make a dedicated YouTube video for that. I think that's going to be what a lot of people want to watch, because you'd have to be truly like dedicated, I think, to go and watch. Probably what I've done is 100 hours so far. The average about 4 or 5 hours per stream, and this is stream 21. It's probably around 100 hours so far, and it's a lot of me repeating the same stuff to just different people. Yeah, so there'll be a highlights video eventually. Oh, and by the way, so I have everything ready to actually assemble the final keyboard. I have all the 3D parts printed. The circuit board is what I'm waiting for. I have all the parts. The last parts got delivered today. And the circuit board is due to arrive at my house on Friday. So a week from now, I should be upgrading from this mini 12-key keyboard to the final thing, assuming that there are no short circuits on the board, and doing the final firmware for it. So realistically, I think the series will end in another couple weeks. We'll be done. I'll have my own custom keyboard. Okay, I don't think I'm gonna have enough time to do the mod tap tonight. Can I do at least a little bit of it? I'd like to have. If I can do a little bit of the mod tap, I'll be back to where I was at the beginning of the stream, but with much cleaner code. So it's basically the starting of the tapping term, right? So the way I did this before was I designated a key like this one to be like, I hacked it to be that if we hold it down, it becomes shift. So can I do the same thing again here, just by hacking this? Yeah, I think what I'll do is right here, we'll say if it's key 0, then instead of adding it immediately, we will start the tapping term. So I have a diagram to explain what this means, by the way. So this is based on QMK. So there's this little nifty little sheet that kind of explains this. So the idea is that you might have a key where it means F if you tap it, but if you hold down the key, it means shift. And the difference is between a tap and a hold is how long you have the key pressed down. So if you have the key pressed down less than what's called the tapping term, which is just a length of time, like a quarter second or something like that, then it's just F. But if you keep holding it down long enough, it means something different. So I wanted to replicate that behavior for my keyboard. I'll need this because I have so few keys. I'll need to have layer switches and modifiers when they're held down and have them be normal keys if they're not. So the way I was doing this before is I had a map in my keyboard state that kept track of when we started holding down a key that was potentially a hold versus tap. So what do I name it? Like, I think last time I named it active keys. Let's not call it active keys. Let me call it something more specific, like I don't know. Tap hold or tap hold timers, hold begin or something. I'm bad with names. Hold start times. Hold start times. So we'll have an index, and then actually, is the index going to be U8? I think it is. And then a U64 for timestamp. What is mod tap? I probably already explained it, but I'll explain it again really quick. MT stands for mod tap, where if you tap it, it's just a normal key, but if you hold it down, it becomes a modifier. So like Shift and Control and Alt and those kinds of keys are called modifiers. So that's why they say mod tap is either a modifier or tapping a key. There's also something called layer tap, which is basically instead of a modifier, it's a layer switch. So you hold down a key, and instead of it being an official Control, Shift, or Alt modifier, it means something internally to the keyboard, which is switch the other keys from one layer to another. So like all the other keys, if I hold down this key, maybe all these keys become number keys, whereas I'm not holding it down, they're letter keys instead. So the more general term, I think, is hold versus tap or hold tap, where the key means something different if you hold it down versus when you just tap it. Okay, so hold start times is a B tree map new. Okay, I'm just going to hack it for now. In scan keys, we're down here, and we're going to say if key index equals 0, else, and we'll put a I don't know, hack fix me. This is a hack to experiment with mod tap. Okay, so the idea is if you press down the special key that might be tap or modifier, depending on how long you hold it down, rather than adding it to our report immediately, we're just going to note the time at which you started holding it down. And then, kind of like that diagram indicates, we make the decision either when you release the key or when the tapping term expires, that amount of time elapses. You can see that's where we actually output something. Rather than or if our output is to add it to the key codes, instead of doing it right when you press down the key, right here, we do it either when we release it or when that timer expires. So it's going to be self.hold start times. Try that again. Dot insert. The key is 0. Actually, just put key index. And the value is now. Because do we have a now? Yeah, now is we sampled the timer at the beginning. Will the PCB use hot swap switch holder, or will you use that? Oh, they're hot swappable. Check it out. I can just pop them right off, even when it's on. Up, I'm pressing it. Yank it out. There we go. So, hot swappable keys. They have the two little pins there. Kind of hard to see on the camera. There we go. Got the light to catch it. And you can see this. The two black dots are... There are holes in the PCB, and there's a socket on the reverse side. Totally safe to do that because really this is just part of the circuit that no power really goes through, so it's totally safe. It's just that as we're doing it, we're getting those, you know, key presses that don't actually exist. It's just the keyboard screaming in pain, really. No, you're not pressing me, you're removing me. Yeah, there's under key LEDs per key. Although on this prototype board, I accidentally wired them backwards. See, it's kind of hard to focus. They shouldn't be shining up. They should be shining down, right? They should be shining through the board, but I designed it backwards. Fixed it on the final keyboard, hopefully, though. There's also going to be 4 underglow LEDs on the final thing. This one doesn't have any. Yeah, that's the reason I made this proto 12 key keyboard, is I wanted to make all my mistakes on this guy so that I have 0 mistakes on the final one. Always expect your first build to have errors and, you know, weird things. Work them out so that the final thing doesn't have them. All right, so then there are two places where we need to make this decision to actually do something, right? One is the tap, which is on release, we need to see, so right down here, we need to see if the key index is in this hold start times, right? So if let some hold time equals self dot hold start times dot get reference key index. Then if it's still there, I think we should call it a actually, yeah, then we're going to remove the modifier, right? So where do I have modifiers right now? Self modifiers, right? Self dot modifiers. We want to clear the shift. I think shift was 2, so we want to and equal 2. Oh, this should be also remove, not just a get, right? Which means we can just pass the key index, I think, right? Oh no, still borrow. And we don't need the whole time. So which means I can just do is sum. Right? I can hide that so you guys can see the code. Making a 12-key keyword, or is it just for testing? It's just testing for a minimal board. I'm making one that'll have this form factor. It's going to be 36 keys. It's inspired by my Korn keyboard, which I'm typing on tonight. Same thing. 3x5 plus 3 thumb on each side. All right, so there's where we turn off the shift key. Let me put another fix me there. And then else that. Okay, so the other place where we want to do this is just a timer in general, right? So outside of any keys being changed, right? So maybe right here? Let me think about this. Oh, it's right here. Okay, so the logic here would be if let hold on. Let me use the same kind of thing where I did with entry. This thing. If it's occupied, right? If let btree map entry occupied entry equals self to hold times dot entry. And we'll just put 0 there because we're experimenting, right? And we don't want to reference 0. We just want 0, the value. Okay. So the idea is that we're not removing it or adding it. We're just seeing, is there an entry 0? Is it occupied with something? Then if now beep 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 minus entry dot get is greater than or equal to some amount of, let's just hard code it, 250 milliseconds, so 250,000 microseconds, right? Then that will satisfy this tapping term, right? If it's, I'm just hard coding it right now to 250 milliseconds, then what we want to do is just turn it into a shift. So we're going to just say self modifiers or equal to, and we're going to remove the entry. Or equal to, and then we'll do entry dot remove. Okay, and then let's print out some things when these things happen. So we'll say deasserting shift. And this is asserting shift. Let's see if this works. Have you seen one of those court typist keyboards? Oh, the stenographers? Oh yeah, those are really cool because you're not just typing keys, you're typing whole key chords. You're holding down 3 keys at once. Yeah, stenography. What kind of keyboard are you using to program now? I'm using a corn keyboard. If you're asking me what kind of keyboard I'm using. And I'm using the Colmac layout, which is why you see me make a lot of errors, because for an untold number of years I've been using QWERTY. I'm still adjusting to the other layout, just because I like silly challenges. Let's program this. 81,920 bytes in my program. It's getting bigger by the moment. Good thing we have like a megabyte of flash to play with. Okay, we have that connection lag. That's just an excuse for me to go check in my code, so let's do that. Oh, what happened to my... Oh, my program got closed. Oops. I didn't mean to do that. Let's run that log again. Connecting. I meant to hit plus here and then say git commit. So this is work in progress. Experiment with mod tap. Still connecting. Lag, lag, lag. What do I do while it lags? I don't know. I guess I gotta raid someone soon, so I should start looking around to see who I should raid next. What mouse do I use? It's a Logitech, the Logitech mouse with a lot of thumb buttons. Hold on, let me find that in my old notebook. I should have like kept this in my bot, but for some reason I removed it. Where did I write this down? Oh, here it is. Logitech G600. I was gonna copy paste it into chat, but then I screwed up my clipboard. Yeah, it's a Logitech G600. That's what it looks like. That's my mouse. Alright, we're running yet. Still not connected? Did I screw up? Oh, I probably have 2 copies of the program running now. It got orphaned, so I need to kill the other one. Hold on. Yeah. I should probably deal with that somehow in my program. Oh, wait a minute. I don't understand why it's not connecting then. Why did it not connect to it? Oh, there it goes. Weird. Okay, anyway, cool. Okay, so we have a bug and that is deasserting shift. It never asserted it. Also, it never asserted in the first place. Okay, I got some bugs to figure out. Oh, also, we never did handle tap correctly. Alright, let's fix the bugs. It never gets into here, probably because it doesn't go in here, and this key is not equal to 0. This has to move out. Yes. So all of this should move out. All of this should move out to here. One more level. Right. So even if there are no changes, we still check that. Okay. Now what about the tap? Tap would be on release. Right, so yeah. I need to actually simulate the key press, right? So we would add the code and then remove it in the next, or remove after a certain amount of time. So we would add that, and then we have to have something else like simulated keys or something. Insert key index now. Yeah, I remember having the simulated keys before, so let's add it back. Oh, we're a little bit back behind in chat. Okay, I didn't see that other question, Tinsby. You said, what's the advantage of the separation so you can hold your hands anywhere? Yeah, basically, it's just to be ergonomical. So that you don't end up tilting your wrist like that. You want your wrist to be natural. So if your arms are naturally like not pointing together, I can't do it with the camera the way I've set it, but you'll end up probably spacing them out and having the keyboard arranged like that because that's how your wrists rest without being tilted. Clemec Mod says it makes it comfortable. Do you feel a difference after changing? Not really. Other than with the Corn keyboard, I don't have to move my wrists as much because there's just aren't as many keys. I don't need to reach as far. Yeah, they're supposed to help with posture. Are those the mouse keys as digits, or do you hold tap long press for that? I don't really use the thumb keys on the mouse other for programming. I use them for games sometimes just because it's easier. If you're games, left-hand keyboard, right-hand mouse. Sometimes left-hand keyboard there's not enough keys, so it's convenient to have the thumb keys there. The numbers just ID the button, not the actual output, you think? No, you can map them to actually to be keys. Don't know exactly how that works, whether it's in the hardware and the software, but they end up being actual keys. Like right here, I'm pressing a button on the mouse right now. Yeah, those happen to be minus and equal. I don't know why. What game in particular? World of Warcraft. So World of Warcraft, you have a lot of buttons. So sometimes it's convenient to map some of them to your thumb. All right. Simulated keys, right? It's another B tree map. It's getting hot in here. I think I need to open the window or something. Actually, what I need to do is end the stream and go to bed. But I'm gonna try to get this in. If I can get the basic mod tap working, then I'll refine it on Wednesday. Do you stream it? No one watches me when I stream it. Would you actually watch me play World of Warcraft? I could. I mean, I just don't think anyone would watch it. You can also make them into key combo like Control C. Yeah. And I'm going to do that with my own keyboard code here. A combo is just turning on modifiers along with actually keys in the array. You would watch me play World of Warcraft, Tinspin? I'm flattered. Maybe I don't know if I'll do it on this channel because it would confuse people to see me go live, but I'm playing a game. But I might do it on one of my other, like, I have like a Ramu Games channel. I might do that sometime. All right, so simulated keys. We add it here. I need to make sure we remove it. The way we want to do it is similar to how we do hold start times. I think we'll just hack it for now. So we'll put it here, right? If it's occupied, simulated keys. Let's have it emulated. I think we figured out that it needed to be emulated for at least 20 milliseconds, right? Then we'll, let's say, simulation of key 0 done, or end. And then remove it from the key codes, basically. Zero. Don't need that. And then here's where we add it. Okay, so oh, hold on. Whether we do that or not depends on how long mod tap was held down for, right? Yeah. So then I do need this if let some. Oh, hold on. This should have gone in the else, because if we asserted shift, we removed it. Yeah, okay, then I got this one a little wrong in this way. I think it's actually always safe to do this. It's always safe to do that, and only if it's none would we deassert that. And then I don't. Actually, that's what I want to do, right? Hold on, let me think about this. We're either deasserting shift there, or we're doing that. We're not doing both. Right, this should be, if there is some else. So if there is a time in there, then we're doing this. Right, okay, and then I should have this go here. Simulation of key 0 start. Yeah, and then we, okay, this is only if key index is 0. Ugly hacks. So if we have a hold start time, then we haven't made the decision yet. If they release it, it's a tap. So we simulate a tap. Otherwise, it's not a tap. It was a mod. So then we're deasserting it when we release it. And that's the assert that matches that deassert. Here's the end that matches this start. That puts it. Okay, let's just try this one. How do you get yourself going after sleeping? Sleeping after coding makes you lose all the cached data in your brain. You wake up blank and lost. Work. After sleeping, I have to work, and that's not all coding. So also exercise. Exercise kind of gets me thinking again. Followed Ryan McGinnis with, oh, thank you, Tinspin. Yeah, it is a lot less followers. Hey there, Cat Peasant. How are you today? Just working on my keyboard firmware here and running into this lag. That lag I hate to deal with because it just throws me off. So I guess, you know what I'll do is it's okay. I'll just make a new commit. I was gonna amend the last commit, but I did push it. So this is attempt to add tap or key tap simulation. Really shouldn't push it immediately. I should wait until I tested it, but that's okay. Oh, it's going. Okay, reprogram. Now we gotta wait for it to connect again. Pretty good, Cat Peasant, except for this connection lag, which annoys me. I'm doing fine. So my final keyboard is on the way. I have all the parts. I'm just missing the PCB. And actually, how did this happen? These two got flipped. I have the 3D parts printed out, so the chassis and the key plates for the final keyboard are ready. Isn't that sexy? So hopefully this weekend I'll have the new keyboard done, and I'll just have some last-minute programming to do. Oh, look, another bounce got debounced for us. That's nice. Okay, so let's tap it. Okay, cool. So that worked exactly what it should have done, right? Raw 1, we debounced a 1, but it didn't actually do anything yet. It just held the key. Actually, we never logged that we held the key. But when we released it, it was less than the tapping term, so then we started a key 0 simulation, and then, yeah, 20 milliseconds later we released it, right? So that means if I were to test this in this window, if I tap it, we get an A. Okay, we're only seeing it some of the time, though. I don't know why. How come I'm only seeing it some of the time? Was 20 milliseconds not long enough? Did it have to be 40? Okay. So we'll tap is working. Almost. Let's see if hold is working. Okay, now... Okay, now so it should be shift should be working, right? So if I... Oh. I don't think it's working. Because shift is stuck. Okay, so... 1 and then shift 1. I don't think it's working. Shift 1, it should have actually shown something different. It's not working. So my modifiers aren't being written correctly, maybe? Okay, two things to look for. The self modifiers, is that actually being used? It should be, because there it is. Oh, that's not right. It should be not to deassert it. Right? Okay, and the other thing was the simulation was too fast. Let's double that to 40 milliseconds. All right, reprogramming. F 10, 11, 12, 13, 14, and reboot. Cool, no lag this time. Okay, Let's see if the tap... Yep. Tap A, and then if I hold it down and press something else, it's a capital. Can't do a capital A because because it's either A or Shift, not both. Okay, cool. It's working. All right, so let's check that in. Fix bugs in mod tap experiment. Okay, here's something that didn't work last time I had this code going before I refactored it. I couldn't shift and then hit something on the other keyboard. Hey, but look, now it works. I can get the symbols. So 1, 2, 3, 4, 5, 6, and then there's shift 1, 2, 3, 4, 5, 6. Or shift B, C, D, E, F. Neat. Cool, okay. So I think I better stop here. So I need to perfect this algorithm, right? We don't freeze modifiers yet, which is something that we need to do for active mod tap. Like if you're holding down one modifier and then you do this, it's supposed to hold the control down, because if you do it, hold it down less than the tapping term, it's like you pressed Control F, right? But if you release Control here, it would look like you hit Control, release Control, and then pressed F, which would be not Control F. And same thing with tap and hold, like when we simulate, or when we, no, it's not the same, sorry. If it's a mod, then we don't want Control and Shift to show at the same time out here, because we delayed the shift out here. So we wouldn't see Control Shift at the same time unless you actually held down Control all the way through. And then I am not doing rolling key presses yet. To do that properly, we have to, I think this is drawn improperly. It should just be Shift and J at the same time, right? And we're not doing that mode. It's this one right here. If we hold it down beyond the tapping term. Actually, I guess it doesn't matter. Oh, no, it does matter. For less than the tapping term, you see it immediately when you release the modifier. You see the Shift J. Oh, but the other thing is that the J is delayed. Right, so we capture the J, we latch it, and we actually re-emulate it out here. Here we do it when the tapping term happens, it comes out there. So I'll have to do that next time. Not enough time tonight. Should we go raid Retro MMO? Haven't raided him in a while. I'm gonna go get some sleep. I hope you guys enjoyed watching. I'm going to continue implementing this stuff on my keyboard. So I've done tap and I've done hold. And I need to get to active mod tap and nested press, and both both variants of nested press, longer or shorter than tapping term. I'll do that next time. When I get this stuff done, though, I'm pretty much done with the firmware, unless I want to do like really crazy stuff like combos. But I'd rather just get the basic stuff working and test out the firmware and actually have a functional keyboard. It'd be really cool to be using the keyboard to develop the keyboard more. So that's my goal for next week. I'll be back hopefully in a couple days. So enjoy Retro MMO's stream. He's working on his own MMO, as you might be able to guess. But thanks for watching. See ya. Bye.